Now let us look at this question. Point masses M1 and M2 are placed at the opposite ends of a rigid rod of length L and negligible mass. The rod is to be set rotating about an axis perpendicular to it. The position of the point P on this rod through which the axis should pass so that the work required to set the rod rotating with angular velocity omega naught is given by. So the concept which is lying behind this situation is that if the rod is carrying some masses at its two ends and the masses are named as M1 and M2 and the work done to rotate it with an initial angular velocity of omega naught will be equals to change in kinetic energy, and that will be equals to half I into omega naught square minus 0. So this work done will be minimum in only one condition, that I of this system is minimum. And for any rigid body, the I minimum always passes through the axis of the center of mass. So we have to calculate this I minimum. All right. Then I minimum will be passing through the center of mass. So if we get the center of mass of these two bodies M1 M2 from this position, let this distance is x where the center of mass is lying. So applying the formula of center of mass xcm equals to m1 into x1 m1 into 0 plus m2 into L divided by m1 plus m2. Okay. Now solving this, x equals to m2 L divided by m1 plus m2 is our answer to this problem. So this is the answer. Option number B is correct. There is another approach to this question where we will differentiate this work done for the case half I into omega naught square, and then equating it with 0 we will get the same relation for x. So to avoid long differentiation and maximum minima scenario, we can use this situation of minimum moment of inertia will be through center of mass. Thank you.